Good morning, everyone. My name is Amanda Martin. I am the Chief Resilience Officer for the state of North Carolina, and welcome today to our latest edition of the Spotlight on Resilience webinar. This webinar, this edition, is focused on understanding climate data, and we have a really fantastic lineup of speakers on this Earth Day. A few reminders as we get going. Today's webinar is being recorded. We're going to have a question and answer session after all of the panelist presentations, but you can put questions into the chat at any time. During the question and answer session, if you'd like to ask a question, please raise your digital hand. We'll call on you and get a chance to ask your question out loud. And please keep your microphones on mute when you are not asking a question. So I want to say a few things about this topic. Climate data is a critical component to building stronger, more resilient communities. We all know that extreme weather events are becoming more frequent in North Carolina, and what keeps us safe isn't just the emergency response or the emergency responders, but the foundation of safety and resilience is about anticipating and preparing for extreme weather and climate change. And what we understand is that communities can flourish even in this climate and this changing climate when they anticipate the possibility of these events and trends. And data is really at the heart of doing that. Data gives us long-term trends about weather. It helps us build infrastructure appropriate for our current and future conditions. It also helps us see blind spots in our own situational awareness or our own local knowledge. It can help us have conversations. It can help us understand things that we're not already kind of seeing with our own eyes, but it also leads us to conversations about how we interpret the data that we do have, and talk about what level of risk is appropriate and how much should we invest to what level of safety. Data can help us prioritize investments in our communities when there is practically an infinite amount of need or areas where we might invest. That data can help us make decisions and make priorities among those options. So I think you'll hear about all of those things and more in color and in context with these speakers. So let me take a brief moment to introduce our speakers for today. First up, we have Kathy Dello. She's the state climatologist of North Carolina. Then we have Matthew Laufer. He's a state hydraulics engineer with North Carolina Department of Transportation. James Alberg, who is GIS and Emerging Technology Manager. That's probably the coolest job title that we have on our roster today with the city of Raleigh. And then we have Mary Roderick from Western North Carolina, who's planning director at the Land of Sky Regional Council. So with that, I'd like to turn it over to our first speaker, Dr. Kathy Dello. And if you give me just one moment, I have a nice introduction for her. Okay, Dr. Dello is director of the North Carolina State Climate Office and the state climatologist of North Carolina, as I mentioned. Dr. Dello leads a team that delivers actionable science-based climate services to support decision-making across sectors, including agriculture, public health, emergency management, and transportation. She's an author of the 2020 North Carolina Climate Science Report, woohoo, and serves as a chapter lead author for the Southeast chapter of the 6th National Climate Assessment. Kathy holds a PhD in environmental sciences from Oregon State University and both a BS and an MS from the State University of New York at Albany in atmospheric science and geography. So Dr. Dello, take it away.
Thanks, Amanda, and thank you, everybody, and please scream if you can't see my slides. I'm really honored to be here on this Earth Day with all of you and talking about a topic that's very near and dear to me. And I've listed all my titles not because of some big ego trip that I'm on, but in this day and age, a lot of people are asking me how we collaborate with state and federal government, and you can see we collaborate well across the state, across NC State University, across NOAA. None of us can do what we're doing alone. We all bring crucial pieces to the table. Now, I have the very tough task of talking to you about climate data in 15 minutes, and anybody who's on this call knows that I can probably talk about it for 15 hours. But I wanted to just center some of our thinking on Earth Day as to why this is so important, what we're doing, and why this is so valuable to our state. And we have this weather network called the North Carolina EcoNet. We have 45 stations around North Carolina. It's 1-minute data. It's really super high quality data. And we have those stations out in beautiful places. And the staff do not complain when they get to go out and service these stations. But for me, it's a reminder that these data points that we see connect to actual people and places and things that are very worth saving here in North Carolina. And I'm also going to start off by saying I'm going to move through a few things very quickly. This is not everything we have, and you should consider me and my team as a resource for you going forward. And especially if we move too fast through anything you think, hey, I really want to know more about that, just reach out. I'm not hard to find. So I've learned in giving a number of talks that people can basically take away 3 things from your talk, and you're going to hear from a number of speakers as well. So I wanted to keep it pretty simple and just frame some of our data as use cases. And we'll talk through each of these, but number 1, you're a flood modeler. It's after Helene, and you want to know about maximum daily rainfall in the storm affected areas. So you've reached out to us. This is a real solicitation that we received. We're rebuilding a bridge. We want to know what future rainfall might look like in Waynesville, or I'm a county health department employee in Fayetteville, and I want to know about how many more hot days we'll see in the future. Now, in parsing these out, we would start to think through, okay, what's the type of data that you're looking for? Is it past? Is it present? Is it future? I'm not going to talk too much about present data right now in this webinar, but I will focus a bit on past, the historical data, and that can be days or months ago or even yesterday. And the future, what do we know about 10, 20, 50, 100 years from now? Now, like I said up front, that we are working across state and federal networks to archive, collaborate, imagine, bring all of our resources together. And we are archiving data from NOAA, we're archiving data from the Forest Service, from our team here at the State Climate Office, and we bring it into one very powerful resource. Now that's going to bring us to the first example. We're running a flood model for Helene. I need to know the rainfall totals within Yancey County. So if you go to our Cardinal data retrieval system, you will get this page with a lot of text and a lock, and I please implore you to keep moving past the account piece, because click on that and you can use your Google account to get into it, but you will need an account to access the data, and it'll become clear why. And it's going to funnel you into a few separate areas. We're going to focus mostly on the request data piece today. But Station Scout is what I like to call when you're sitting on your couch, and this is what I do, and thinking through, it feels like it's been very warm lately, or I want to know how much rain has fallen over the past 2 weeks, and you don't want to do a lot of work to get to that information. Station Scout's the place you want to go. Also, if you want to learn more about the data that we have available, the stations that are recording, that's where you want to start. But if you want a lot of data, you're a flood modeler, you say, give it all to me, you're going to focus over here on the request data piece. This is where you get access to our entire database. We have terabytes of data, and it's all free for you to use. So again, push past the account piece, get to the request data page. Now, I know it's really tough sometimes to walk through data presentations when they aren't giving you the website, but we have this request builder set up for you, and it should be really easy for you to select what you need. Here I have a predefined region. We're going to have Yancey County there. For the time period, I'm going to pick the days where we had the predecessor rain event from Helene and the day after, just to capture anything that maybe happened after the time period. I'm going to say, give me all your total precipitation and go off and tell me what you have, State Climate Office. And the request builder will come back, okay, we have 7 stations in Yancey County. Here's the data that they've recorded. If you pull down on any of those menus, it will tell you how complete the data are, if we're missing any data. But you'll see a few stations here that were really crucial during Helene. Mount Mitchell State Park is our station. It recorded the top wind gust during Helene, and the Busick Raws recorded the top rainfall total during Helene. So Yancey County was particularly hard hit. All these data are there for you. You put in your request. It churns through our database. Sometimes it'll take a minute or two, but then it will pop up. The request will be saved for you. You can download it. I will caveat that sometimes you will hit a data limit each month. If that's the case, just reach out. We have that in place so people aren't hitting up our servers constantly and bogging things down. But there have been very few times where someone's reached out and we've said, no, you can't have more data. We want you to have our data. Now, I'm going to talk just briefly a bit about this tool that we've built to visualize rainfall intensity, duration, and frequency curves in North Carolina in partnership with the North Carolina Department of Transportation and also NCORE, both groups on this webinar, so you'll hear more from Matt Laufer. But essentially, we're building infrastructure that needs to last more than a year or two. It needs to last through the next Helene or the next Florence. And one of the things that our group did is we got together with folks in state agencies like Matt, who are thinking, okay, we need to be thinking about our future in a way that's not like the past. And we know that the federal government has these helpful precipitation curves, and that's what we're using to design our infrastructure, but they're out of date. Here in North Carolina, that's Atlas 14. And the data only go through 2000. So we are living in a completely different climate in 2025 than we were in 2000. And we got a bunch of smart people together and we built them a tool. This tool is hot off the presses. It is still in beta mode. We are still taking all sorts of feedback on it, but this puts the power of that Atlas 14, so that's the top data set on the top, those old precipitation curves that NOAA had produced that were a little bit out of date, but still useful, and then adds in climate projections on the bottom. So you select all of your variables and your duration and your return periods on the top, and you can create a map that will show you what you should be expecting maybe mid-century or the end of century. So here I pulled out Waynesville. You've got the Atlas 14 on top. So again, the historical projections, the 24-hour precip depth for the 500-year storm, so a pretty significant storm. And then what that looks like in a warmer climate, a more aggressive emission scenario, so a little bit more business as usual for that same storm. So you see an increase between the two values. And then if you want more than a map, we have all of the data available for you at all the different frequencies with all the different scenarios that you can download and then use in your planning. But I'll let Matt talk a little bit more to this one. So I'm going to zoom on next to our third use case. You're at a county health department, you're in Fayetteville, and you want to know how many more extremely hot days we should expect in the future, right? It was 90 just a couple of weeks ago. We're already thinking hot weather here in North Carolina. How many more of those days are we going to see maybe mid-century, 2050, 2060? That's going to take you to a tool that we developed called Canvas, and you'll get all the links at the end, but you put in your location, and here I've picked Fayetteville, and you will pick your climate projection on the side and the variable that you want, and here I've picked extreme maximum temperatures, which we've defined as 95 degrees Fahrenheit. This is meant to be a little bit technical. It is meant to be for people who know the ins and outs of these climate projections, who maybe love a box plot. But again, I'm here as a resource if you need help with any of this. But let's say the box plot isn't doing it for you. You're a map person. We can then click on that value and get you some snapshots and some maps. For both scenarios, RCP 4.5 is a little bit more of a greenhouse gas reduction scenario, move toward renewables. RCP 8.5 is a little more aggressive on the fossil fuels. And you can poke around with all these tools, and we have all different sorts of climate variables in there. I know I'm coming up on time. Who's using our data? Researchers, students, engineers, construction, lawyers, media, doctors, ranchers, agriculture, extension, and hopefully you. So with that, just a few sources, and I know Nicole will be putting these in the chat. Cardinal is you want lots of data. Station Scout is, again, you're sitting on your couch, maybe half paying attention to TV, and you want to briefly glance at the data. Raindrop is that new IDF curve tool. Canvas is the one for climate projections. And again, I am a resource. We just went through a lot of things fast. So we will have time for questions at the end, and I'm going to turn it back over to Amanda.
Thank you, Dr. Dello. That was amazing. And now, instead of scrolling social media in front of the TV, I'm just going to drop on over to Station Scout and check out some climate data. All right, so turning next to Matt Laufer with North Carolina Department of Transportation. Matt Laufer is a state hydraulics engineer for North Carolina. He works in the Department of Transportation's hydraulics unit, and he's been with the department for 26 years. The hydraulics unit supports design and operations, and he manages the department's compliance for stormwater and floodplain management. In addition to the unit head responsibilities, he takes an active role in the department's resilience program. He's a member of the Transportation Research Board TRB Committee on Hydrology, Hydraulics, and Stormwater, and is a member of the AASHTO Committee of Design and Technical Committee on Hydrology and Hydraulics. I'll let someone correct me there. I think I might have missed a word. Matt holds a Bachelor of Science in Civil Engineering from The Ohio State University, and he's a registered professional engineer in North Carolina. So Matt, take it away.
Hey, thanks, Amanda. Yeah, I really appreciate the opportunity to just come talk to you all today. And also just appreciate Nicole and Amanda getting us together here, and appreciate Kurt and Brian who are joining us on the call from the hydraulics unit, just the support they give in implementing this program. So just want to talk about rebuilding transportation infrastructure with greater resilience. Just touch upon some of those key topics. So the definition we've adopted is basically the federal highway definition. Resilience is the ability to anticipate, prepare for, and adapt to changing conditions, and withstand, respond to, and recover rapidly from disruption. So I'm just going to talk about that, how we're kind of embracing this definition at DOT. I think one of the important concepts, even today, we're dealing with this, is that the climate is changing, and we had Kathy on here just talking about the climate science report, who she co-authored that on, and it's a really good report. I think just some information that's coming out of there is like, there is a statistically significant upward trend with our extreme precipitation, and we're seeing that, and that's something to document. We can quantitatively assess that through our analysis of the data. So we see this trend. As engineers, we need to start designing to those trends, because if we don't, then we're not really taking into account the information and protecting the public as we need to. But we also know these trends are most likely to continue. So as we look forward into the future, what kind of additional resilience do we need to implement, and how do we do that effectively? There's the other part is the risk associated with the storms we're experiencing. And we've experienced some really big ones in North Carolina. Ones that had significant impact on the transportation infrastructure were Matthew in 2016. I honestly thought that was the storm of a career. And so that, flooded I-95, significantly put it underwater for about a week. And we lost about 800 structures, pipes, and things out of that. And then we had Florence in 2018, and that was very significant. That paralyzed our transportation network. I-40 was under a week. I-95 was under a week. Significant flooding. Wilmington was cut off. You couldn't get there by land. So we had significant challenges in reacting to, responding to, recovering from Florence. So we've been doing a lot of work since Florence, trying to understand better how we can react to these events. But then just this last year, 2024, we had 30 inches of rainfall in Busick and 24 inches of rain on top of Mount Mitchell, and then just a significant amount of precipitation throughout the Appalachian Mountains out there in Western North Carolina, and it was very significant. In fact, from 1999 to basically the fall of 2024, we spent about $1.2 billion on all hurricanes, all damages from all these events over the years. And in 48 hours, Helene caused $5 billion worth of damage to North Carolina transportation infrastructure alone. So the magnitude of that, the planning future is, how do we do that well? So I just want to step really quickly through our program. We've got a program that's a life cycle program looking at setting up a solid program within DOT, long range planning, design, construction, maintenance, and operations. So we're thinking about the whole life cycle of that process and how do we integrate it in the department. And a lot of that's through collaboration. We have a resilience program management team at DOT that is supported by our Office of Strategic Initiatives and Program Support and Federal Highways. And then we have our NPO, RPO partners. And then we've got multimodal transportation as well as our technical support from like Division of Highways and Highway Operations. And that's just basically to facilitate a program that's based on policy, program, and practice. There's a RAND study that really talks about objectives with respect to transportation. So the 4 R's of redundancy, robustness, resourcefulness, rapidity. And then you can look up that report, but it's just how does our system do as well with absorptive capacity, restorative capacity, adaptive capacity, and equitable access. So we've basically structured our program around these concepts. And I want to not underemphasize, because it's the most important part of this is partnerships. We have really strong partnerships in North Carolina, and that's what actually makes us really successful. And Kathy, I apologize, I don't have STO on there. I need to put that on there. So I was putting these slides together, but State Climate Office is another significant partner there. But the cabinet agencies, our university systems are key to continued resilience in North Carolina. So I just want to talk a little bit about our flood warning and planning tools. That's the other part of resilience, planning for, preparing for. Kurt's on this call, but and Brian, they support this program. But we've got about 3 tools that we use just for preparing for, responding to, recovering quicker from flood events. Our Feynman-based tool, Flood Inundation Mapping Alert Network, for showing flood inundation on our road network. TSAP's our Surge Analysis Predictive Program, which helps us understand where surge is going to hit and what roads it's going to hit ahead of the storm. So before landfall, we're predicting where our roadways and bridges are going to be impacted by the storm, which really helps us prepare for and basically position resources or even get resources out of the way. So if we know a maintenance yard is going to get flooded by surge, we can tell them 24 or 48 hours ahead of time and then get the equipment out so it doesn't get damaged. And then we have Bridge Watch, which is monitoring all of our large bridge structures and culverts. So we have about 15,800 structures in that system, maybe even more, that are monitoring 24/7 rainfall over the watershed areas of tributary to those structures. If there's a gauge there, we're also monitoring water surface elevation with respect to the bridge. So that can tell us when the bridge is needs to be closed or is overtopped and that type of thing. Gives us a understanding of its vulnerability and how we can respond to it. In addition to that, we got a lot of tools we're using for roadway inundation tools and the CRIS tool. Those are our roadway inundation for the areas outside our coastal areas, as well as our coastal roadway inundation tools. So those are really helpful in planning, understanding where we have vulnerabilities and things. The flood warning planning tools, this is Feynman. I just wanted to highlight Feynman real quick. I'm going to click through these and bring these up. There's quite a few in here, and then I'll talk about it. But Feynman is a partnership program between EM, North Carolina Emergency Management, and also DOT. And Emergency Management started this tool back in like 2006 and has been developing it. It really had a transformation and was used heavily during Florence. And during Florence, we realized we didn't have the roadway network. So since Florence 2018, we've been building together a more robust system that really helps us understand the impacts on our highway system. How severe is the flooding? How high is the water? When is it going to be flooding? Do scenario analysis. It also has the buildings in there, so you can kind of see what structures are impacted, building structures. as well as bridges and those type of things. So very important tool for understanding how floodwaters are impacting our network. It also has a forecasting tool in it, and I just want to emphasize the importance of that during Helene. Kurt and his team were able to, working with our Transportation Operations Center, we were able to tell Division 13 that I-40 was going to overtop 24 hours before it did. And that allowed them to put emergency vehicles out there. And according to Division 13 Transportation Systems Operations Engineer, he said we saved lives because they knew that that was going to happen. Otherwise, people would have been driving on it and swept into the French Broad. So that was a pretty big success for us, and how we respond to and prepare for these hurricane events. We also have planning tools. A lot of them. This one's a RIT tool, road inundation tool. Again, this can help us do our vulnerability assessments, understand how water is affecting our roadway network. There's a lot of information in here, as you can see as I'm clicking through this. Kurt gave a presentation on this last week at Campo. But a lot of information on elevation of the roadway network, and also the elevation of the road, the water surface elevation, and we have it for multi-frequencies, 10, 25, 50, 100, 500 year. And then we also have additional futures precipitation scenarios in there as well for flooding events. So pretty helpful tool for doing planning and resilience, incorporating it into. And then we also have a RAF tool, our resiliency analysis tool for our transportation network. So we have a lot of tools in here, like our RIT tool and our CRIS tool, but we're also putting other things in here as well, and some of those are listed here. So this is really Kurt's tool that he's developing heavily, and working with our partners to give us better assessment of our roadway networks, and also help our planning engineers and things like that, our MPOs and RPOs. I think another one that we're adding in here is just our bridge wave analysis and sea level rise and scour predictor in there. So those tools are coming online, and we're incorporating those as we go along. It's also coordinated pretty tightly with the resiliency blueprint, or DEQ, and they're helping taking some of this information and incorporating into that as well. So that's our resiliency analysis tool for transportation. Then, so how are we integrating resiliency into our projects? How are we doing on time? Getting close, so I'll kind of speed through these. Want to just mention I-95. After we had Florence and it was inundated for a week, we worked to use rain on grid modeling to identify an improvement to and elevating I-95 corridor. So in the middle of design, we actually changed the design, and it is now designed to basically facilitate a Florence and a Matthew into the future. We're also investing in living shoreline improvements, and so this one's on NC-24 between Swansboro and Cedar Point, and this is to protect overtopping and help protect that facility for future sea level rise and wave action. But a couple things, just talking about Helene real quick. So you'll see $9 billion on here. There's a lot of other damages to the transportation network that were not only DOT, but others. So this was issued by the governor back in October 23rd of just the total destruction. So significant damage to our infrastructure, our roads, our bridges. We had over 800 bridges damaged, 150 bridges totally washed out, and then miles and miles and miles of road and river destroyed. And so what are we learning from that? How do we build back more resilient? We look at our structures. How do they fail? How do we make them more resilient? So these two structures are just about, I don't know, 1/10 of a mile from each other. So the arch culvert put on bedrock survived, but these culverts here that were basically didn't have head walls and were not anchored in well, just moved. So when we go and replace these, we'll build them back stronger and better. Again, we also saw failures of different bridge systems, how they were built, drilled shafts versus spread footers anchored into bedrock. And so when we go back, we'll know what worked better, wing walls and things. So as we go back through design on those 150 bridges, we're implementing different resilient strategies. And then we also just need to think about those corridors that got damaged significant. This is just on the Cane River, down on 19W in Yancey County. And so this is just a picture of, this is a depiction by Colorado DOT when they had the big Thompson floods, but same kind of concept. But all that hatched area is what we lost, mass failure. Most of the road was destroyed, that type of thing. And then when we go back and build back, how do we build back better? So going back and putting more resilient infrastructure in on the embankments and things, and also using the right rainfall and future conditions for the service life of the facility. So Kathy touched upon about that. So we're using the raindrop tool to do the modeling for the future and understanding kind of what those flows are compared to what they are today to build back better and show that. And then just real quick, I wanted to mention the Resilience Coalition white paper that's out there, summary of finding. It's a really good document. You can Google it. But it just talks about the document gaps in knowledge, our data, our capacity and tools, identifies additional barriers to implementing climate resilience, and then it develops recommendations for next steps. So I know that was a lot of information, but just wanted to kind of highlight some of the things we're doing for resilience in transportation. Please feel free to reach out to Kurt or myself or even Brian, and we can give you some more information. So thanks for the time. Appreciate it.
Thank you, Matt. That was a fantastic presentation, and I love when Matt and the folks at DOT present, because I always learn something. I'm not an engineer, but I just wanted to highlight a few things that you heard him say, which is that when we have this kind of data, we save lives. Literally lives were saved in Helene because they were able to predict where I-40 would overtop. And the kind of data that we have in North Carolina, not every state has these resources. North Carolina, we are really lucky to be such a data-rich state. So I really want to call out the ways in which we benefit, because it's not always, you know, to the average person on the street, they might not recognize how much hard work this data is doing for us. And of course, all the talented folks like Matt and his team at DOT who are making that data work. So thank you. For our next speaker, we have something a little bit different. I'm really excited to welcome Jim Alberg. He's with the City of Raleigh Department of IT. He serves as Raleigh's GIS and Emerging Technology Manager and collaborates with a dedicated team of developers, analysts, and technologists. Over the past decade, he's emphasized relationship building and professional development in various technology management roles, delivering digital solutions that benefit both internal and public users. Prior to joining City of Raleigh, Jim worked in GIS technology roles with the City of Boston, which happens to be my hometown. He remains committed to public service and using technology to improve and enhance the lives of all Raleigh's constituents. So welcome, Jim.
Thank you, Amanda. Can you just verify you can see my screen?
We can see your screen.
Awesome. Excellent. Great to be here. Want to echo what Amanda just shared. I've already learned a ton. Unfortunately, I now have tons of research work that I need to do on some of these data assets that the previous two speakers shared, because they're really amazing, and agree we're really lucky in the city, in the state, to have amazing amounts of data. So I promise we didn't coordinate the presentations beforehand, but I think I'm going to kind of echo a lot of the things that were shared. So some of the things that we're lucky enough to have in the city and in the capital region is we're one of the fastest growing areas in the country. I think that exacerbates some of the kind of climate change and weather events that we're going to see, and the way that our citizens experience climate change in our city. One of my roles is to try and take some of the data that we had talked about and turn it into insights or information to help make city officials allow them to make data-driven decisions. I'm going to talk a little bit about a couple of projects that we're working on where we're trying to take lots and lots of data and turn it into actionable information. And we use it in try and use it in 3 different ways. So one is storytelling and education. And so try and use data and insights to educate both internal staff as well as the community around what's happening in the city and the region. 2 is analysis, which is kind of obvious. We try and use this data to help make data-driven decisions. And then 3rd is an area that we're trying to mature in, which is to measure outcomes to see if, as we make these decisions, do they make sense? Were we able to move the needle? So in 2021, the city partnered with NOAA to do a data collection around surface temperature. Our sustainability office will gloat about how we had the highest volunteer rate in the country of the cities that were selected. They went out with devices to measure surface temperature on a hot day in July, and we ended up getting a surface temperature model for morning, afternoon, and evening. And this was a proxy for how people are experiencing heat in our city. And when we got this data, we didn't, it wasn't obvious exactly how to leverage this. And so we tried to use it in the 3 ways that I kind of described. 1 was around storytelling and education, 2 was around analysis, and 3 is, can we use it as a data point for measuring outcomes as we start to put in mitigation steps? So one of the things I'm pretty passionate about is using digital twins, which is a virtual representation of our city, and use this as a mechanism for education. We thought kind of visualizing data in 3D was a way that might be a little bit more engaging for the average citizen or staff member to view. So we just kind of incorporated it into our digital twin. Secondly, what that did was that allowed us to leverage a kind of enterprise platform, GIS platform in the city, which made the data available to practitioners within departments to leverage for other projects. And so what we started to see is that people started to incorporate it into existing initiatives that were going on. So there was a street tree equity project that was in flight to try and identify where in the city were the highest priority for tree plantings related to empty wells in the city. And so when we have a good street tree inventory and we know where there are opportunities related to density and open tree wells. And so we leveraged that data along with this heat data to identify those areas that were the highest priority for those tree plantings. And so, as you'll see on the slide, some of the obvious stuff the benefits of increased tree canopy around the city and how people are experiencing heat within our city on a day-to-day basis. Next is a kind of an innovative project around cool streets, which is the city was in 2021 was looking at piloting applying titanium dioxide to some streets to increase its reflectivity. Interestingly enough, I am definitely not a transportation engineer by any stretch, but at Texas A&M, there's actually an institute that measures pavement and pavement characteristics. And so the city and the vendors that were applying titanium dioxide to streets did some analysis on what the effect of applying this coating to rejuvenated streets might be. And it's really phenomenal. As you can see in the slide, 376% increase in reflectivity from untreated streets. And so this is a fairly expensive proposal. And so since 2021, we have used heat data to identify those areas in the city to help prioritize those areas in the city where this treatment was appropriate and kind of use this data to drive that titanium dioxide application. Another project. So because of this work, we did a little bit of marketing around that work. MITRE, which is a research firm in DC that does a lot of federal work, reached out around partnering with us to develop a microclimate modeling engine. And so what it is it uses some DoD plume technology, some NOAA weather data, and a physics model to do microclimate modeling. So this is as high resolution as 1 meter by 1 meter resolution. And it is a machine learning model that takes in a bunch of historic data and this physics-based model, as well as our digital twin. I had talked about that earlier, our 3D environment of our built environment, and does some models and scenarios based on wind speeds, direction, and ambient temperature to model things like wind speed, temperature, real field temperature, heat index, etc. And we got excited about this in an opportunity to not only model existing conditions, but potentially model future conditions. So this is this idea of, as developments are being proposed in the city or as zoning changes are being proposed in the city, being able to understand what impact that might have in some future scenario. So as I mentioned, one of the real benefits for us is trying to make the data, my team is small but mighty. And there are a lot of passionate people working on climate related initiatives and capital improvement projects in the city. So what we're trying to do is make this data available for them. And so one of the key initiatives that we're working on is developing an equity index. And just to kind of digress real quick, when we think about equity, we try and think of it both holistically as well as within specific verticals. So this represents some early work where we were doing work related to specific initiatives related to equity. And while it was moving the needle, it was very much ad hoc and opportunistic. We didn't have a single way to think about equity in the city. And so what we've tried to do is create a little bit more strategic view on equity. And so we've started to create a number of these equity indexes within the city, some of them demographic, but I think relevant for this discussion is an environmental index. And so that environmental index also includes some of that heat index data, as well as some of the data that I think Kathy was mentioning earlier from the federal government related to pollution. And so this gives us this ability to kind of share broadly across the city an equity index that we can use to drive initiatives and decision making, as well as making sure that we have representative engagement from the community. And so we've started to kind of roll this out. This is definitely a work in progress. We started with housing, and then the next group we actually worked with Nicole when she was part of the city around environmental justice, and then digital equity is right behind that. So the last thing is something that Matthew mentioned, which is partnerships are key, right? We have a small and mighty team, so really working with departments is important. And the reason I have this animation is sometimes we're pulling departments and we're dragging them through innovation, and sometimes they're dragging us. And so being part of this webinar, I will be able to follow up on some of the amazing work that Kathy and Matthew are doing, and that will propel the city forward. And hopefully, they can learn some things about what we're working on as well. So the last thing I want to last two things I wanted to kind of end with is that this data, as I mentioned, one of my jobs is to try and help people take this data and turn it into insights. And so we're trying to make this data available across all of the platforms that we have so that practitioners can use this data in all sorts of things, whether it be in micromobility planning or capital improvement program planning, et cetera. And the last thing I'm just going to end with is, in my experience, we are very lucky to live in North Carolina with lots and lots of data, but really it's about the people. And the people, when we talk about people, we talk about them in three different ways. One is the team. So I'm lucky enough to work with people who are passionate, curious, and have an aptitude to learn. Two is working with departments who have an expectation that they're going to do things differently going forward. And third is the community. So the community, they put a lot of pressure on us to deliver better solutions, think differently, which I think is an opportunity. So that's it. Thank you, Amanda.
Thank you, Jim. What a fantastic presentation and a great reminder of it's one thing to have the data and another thing to make it mean something and bring it to life and ensure that it's helpful for decision making. So thank you for walking us through some of the pieces of that part as well. Okay, so and as a reminder, please be thinking of your questions. You're welcome to put questions into the chat. We'll have a Q&A session after our last speaker, who is Mary Roderick. Mary Roderick is the Planning Director for the Land of Sky Regional Council, which is the council of governments based in Asheville. Land of Sky serves 4 counties and 16 municipalities. And they're very lucky to have Dr. Roderick, who works primarily in watershed restoration and stormwater management, as well as on water and sewer infrastructure system development. Other areas of concentration include climate resilience planning and hazard mitigation. Dr. Roderick completed her interdisciplinary PhD in urban design and planning at the University of Washington with research focused on geodesign-based multi-scalar and multifunctional green infrastructure planning. Dr. Roderick also has an MA in community planning with an environmental specialization from the University of Cincinnati. Welcome, Mary.
Sorry, I just realized I was muted. Can everyone see my screen?
Yes.
It's not showing me the box that I'm used to seeing.
And I put this in the chat, but if you need the screen to be larger or the slides to be larger, you should have a zoom in or zoom out button above the presentation and below the speaker cameras. So Mary, take it away.
Great. Good morning, everyone. I likewise am super inspired by all of the presentations that came before me and also have lots of homework. And we're meeting with the city of Asheville tomorrow about their climate justice mapping work and integrating our regional resilience assessment data into that. And so I think I'm going to have to do a quick deep dive into some of what the city of Raleigh is doing. So I may be following up with you, James, after this presentation. I'm going to talk about how we're using climate data in the Land of Sky Regional Resilience Assessment. But first, I really think I want to touch on why regional resilience, because many of you may not be familiar with COGS and what we do. Of course, people rely on assets and services that cross jurisdictions. Hazards do not recognize jurisdictional boundaries, as we know. And we work at the scale and also across multiple planning areas, economic and community development, housing, workforce, aging, transportation. So we touch a lot of spheres in our region, and we have the ability to support the integration of hazard mitigation and adaptive capacity into a wide range of areas because we help develop, fund, and implement projects throughout the region. So in areas of land use and development, infrastructure, transportation, watershed plans, stormwater management, broadband, we really are able to kind of help our local jurisdictions and figure out regional solutions to address vulnerability and increase resilience. We started our work on the regional resilience assessment back in 2017. I'm not going to talk through this whole timeline. I just want to say, it's been a process. There have been several phases, lots of different funding sources, and we're currently here in phase 4, where we are completing our vulnerability and risk assessments, at least kind of the first pass of them. Obviously, they need to continually be updated, and identifying priority strategies for implementation. Of course, this work has been pretty heavily impacted and now influenced by Hurricane Helene, and I'll talk more about that. Oops, I'm going the wrong way. So, of course, hazards existed due to climate before climate change, although climate change has been happening for a long time. But I've got a couple of orange boxes here on things I want to highlight from the Climate Risk Assessment and Resilience Report. The likely increase in hurricane intensity, in droughts, and in precipitation leading to inland flooding. I would say that's not just likely, but very definite. Certainly based on our experience with Helene, and here an excerpt from a blog that Kathy co-authored in January, highlighting some of the things we experienced in 2024, in addition to Helene, and between a summer and fall drought, there were several other large storms that dumped a lot of rainfall across the state. So, we are very much living this that, was outlined in 2020 today. These climate stressors combine with non-climate stressors like population growth and development, to create the threats and hazards that impact our people and infrastructure. And of course, we're interested in not only the exposure to these hazards, but also vulnerability and risk. All of this we're doing following this methodology outlined in the Climate Resilience Toolkit, where we first look at exposure, assess vulnerability and risk, investigate options to address this, and then, of course, prioritize and plan in order to implement those things. Equity is also centered in our work. We do incorporate the CDC's Social Vulnerability Index right now at the census tract scale. And in our current work, we're looking at how to drill down. So that's another reason I'm going to look at the City of Raleigh's work. A little more detail about the specific assets that we're looking at. Of course, residents and residential property, commercial property, government and critical facilities, and roads and mobility, which we've heard a good bit about from Matt earlier. The hazards that we consider in our region are both current and future flooding, landslides, and wildfire. And we've seen the interaction of all three of these during and after Helene, with wildfires still burning across our region. Our analysis incorporates some new hazard data, although I've gotten some more ideas from these presentations, so we'll see what else we can do. But in addition to the regulatory floodplains from FEMA, we're now also utilizing North Carolina Emergency Management's advisory flood data, which includes the 25-year and the 1,000-year floodplain. And that gets at these storm frequencies, basically. That's just a static representation of these frequencies that we're interested in. We're also integrating the North Carolina Geologic Surveys, debris flow pathways. We now have them for our entire region, not just Buncombe and Henderson counties, as well as a probability of sliding data layer. And finally, for wildfire, the U.S. Forest Service has a new data set that looks at risk to structures, as well as now Hurricane Helene storm damage. So areas that were severely damaged and areas that were possibly damaged. And I'll talk more about how we use that data in just a moment. I just want to kind of outline the data sources. But all of that, is used to really look at the vulnerability and risk. In this case, all three of these homes have the same exposure to flooding, but their level of vulnerability varies based on their elevation. And in our analysis, we're able to look at, structure by structure, when was that structure built, and was it built before or after base flood elevation or BFE standards were adopted in the jurisdiction. So we're kind of really drilling down at the parcel scale and structural scale and looking at the regulatory environment to try to understand how each individual structure may be vulnerable as one of the sets of factors that we use. So we combine, I got a little ahead of myself, we combine these assets with these hazard layers and stakeholder input to help us identify, and you can't read this, but down here in the tool, you can really click on each asset threat pair and see what the criteria are that we're using to determine vulnerability and risk. And again, you can't read this, but this information and these attributes are really informed by our stakeholder outreach and engagement. And we have an upcoming meeting because we're just now getting into kind of the deep dive for both natural resources and government and critical infrastructure, and bringing together people in just next week to drill down into what are the key characteristics for vulnerability and risk that we should be looking at. So all of this lives in an interactive platform called ExcelAdapt. This is an excerpt from the overview page and shows the red maps are vulnerability and risk at the census tract scale. The blue maps are still those that are just exposure, where we have not yet done that vulnerability and risk assessment, but are in the process of doing that right now. So eventually all of our maps will be red. We won't have any more blue maps. Again, this grid just shows kind of across the top all of the different asset classes, and across the side the different hazards. We will be adding this vulnerability, this advisory flood layer to our matrix, and all of these maps will be vulnerability and risk, not just exposure, as some of them still are. Looking at that in more detail, so the difference, we've already started running our analysis, we just haven't put it into our production environment, or we've already been running the analysis, it's just not in production yet. But there are many, many more areas here with high flood vulnerability when we use the advisory flood data. You see some areas on this map to the left are white because they're not regulated, they're not considered in the FEMA regulatory floodplains. At the parcel scale, you see that as well, and just how many more structures are exposed. In this case, we haven't yet done the VR at this level. I'm going to skip that. For the wildfire, this is a super complex graphic. I just want to say on the left is showing the level of damage from Helene, from none to severe. And along the bottom, it's showing the background soil moisture that creates this kind of background level of fire hazard from wet to dry. And the quadrant we're really interested in is here in the upper right. And this next slide simplifies that. You see that same little quadrant, and it shows us the number of structures that are in these areas of severe blowdown and very dry soils. So, we see many of those structures are in Buncombe and Henderson counties. Finally, for landslides, our initial analysis shows that 90% of the structure impacts from landslides, this isn't just in Henderson County where we've done this analysis so far, were in areas of debris flow pathways. So we're basically taking this modeled data and trying to compare it to actuals, essentially in a way we can ground truth what we're doing. For transportation access, and I definitely want to look at map slides in more detail, we're again still here using the regulatory floodplains to determine where the roads may be disconnected. Those are the pink roads, and the parcels that are disconnected due to flooding and landslides. We've also incorporated information around emergency and health services to look at where there may be disconnects in access there. This slide summarizes lots of numbers I'm not going to be able to talk through, but I was concerned, we did this analysis last summer, and I was concerned about the high percentages in the connectivity area, but we saw in Helene that we did in fact have that level of impact. So I think that these numbers are reflective of potential disconnects due to flooding and landslides, and none of this accounts for the down trees, power lines, massive amounts of debris, and I don't know that we will ever be able to model that, but that does bother me, I'll say. So I'm going to skip through these. Just know that we are looking right now at the impacts from Helene And we do already incorporate historic data in XLAdapt, so you can turn on historic wildfire and landslide data. And we will be also incorporating the Helene impacts so that people can compare the modeled information to actuals when they're doing their analysis. We do all of this to investigate options, of course, to address this vulnerability and risk through a whole of government approach. So that means, policies, land use, where we're investing in natural infrastructure, where we need to build more capacity in communities. It really is a whole suite of actions that we have to take. And I know I'm running short on time, so I'll say we currently have BRIC funding, both to update and complete our vulnerability and risk assessments, as well as do this kind of detailed crosswalk between our resilience assessment and our findings and local plans and ordinances to make recommendations about improvements that we need to be pursuing. I'm going to skip the options database, but I have all these slides here so that you can look at this later. Some of this lives on the Resilience Exchange, some of this lives on the Climate Resilience Toolkit, but these are essentially all these different tools that we have to address vulnerability and risk and increase resilience. Again, I'm going to skip this. We are working, like in Buncombe County, to incorporate this information into comprehensive planning exercises, or into not just exercises, into comprehensive plans. And of course, we're implementing projects on the ground already. Several projects have been informed by all of this analysis. In the city of Hendersonville, we're doing a large flood risk reduction project at the intersection of Greenville and Spartanburg highways, just south of downtown, where we're reconnecting Mud Creek's floodplain across multiple parcels, and doing some really interesting stormwater management there as well. In the city of Asheville, along the Swannanoa River Road corridor, we've used the analysis to help us look at flood mitigation strategies. And in the city of Brevard, kind of at a very small scale in the Times Arcade Alley to implement stormwater improvements. So, this data is being used actively, both for planning and for project implementation in our region. And obviously, we have a lot more work to do. Here is the access to XLAdapt. It is password protected, but you can request an account, and we will approve you. My email address and phone number, and all of our vulnerability, all of our resilience assessment reports are available. I know that was really quick, and I apologize, but there's a lot more information in the slides that you can look at after. Thank you.
Thank you, Mary. And don't go too far, because we're going to move into the question and answer session of the webinar. And folks, to remind you, you're welcome to put your question into the chat, or if you want to ask your question out loud, please just raise your hand. It's in the bottom, or at least on my screen, it's on the bottom bar. It says raise, and there's a picture of a hand. I wanted to kick us off with a question for Mary, and this might have been something you were going to share at the end, which is just if you would talk to us a little bit more about how you work with local governments, because you've been sharing, and all of our partners on this webinar are sharing complex data. And one of the challenges that we all face is bringing this complex data and making it meaningful to people who aren't looking at it day in and day out. And so I'm curious, Mary, when you start working with local governments, like, do they approach you with, hey, I have this problem area, I don't know what to do? Or do you come to them saying, hey, we've looked at the region and this area really lights up as a big vulnerability? So I'm just curious if you would be able to talk us through that process a little bit.
Absolutely. And I didn't realize my video wasn't on until I just, sorry about that, y'all. The slides are hopefully more interesting to look at than me. So it's both, Amanda, really. Sometimes it's opportunistic, like the City of Hendersonville project. I mean, they know that there's flooding there, and they already own 2 properties. They want to acquire 3 more right next to Jackson Park to create all this contiguous space for flood mitigation. And so we use, in working with the stormwater administrator, and he says, hey, let's pursue grant funding, and then we use ExcelAdapt to essentially quantify vulnerability and risk and create good maps and numbers, right? The amount of commercial property, the level of social vulnerability. Like, we're able essentially to, just to provide all this great data to secure funding, and we did secure it. It's actually, now we've had one grant increase, so we're close to $4 million, 3 different grant sources. We got all the funding we looked at. And so I think it's, it really helps to have this source of data to support those grant applications and that project development. We didn't need that to identify the problem, right? We knew the problem was there. But in other cases, a funding program will come out, like Golden Leaf's flood mitigation program, and I'll know that, a community is working on something. Like Woodfin has been working on their Greenway Blueway, and I'll bring up ExcelAdapt and I'll say, well, what is the level of vulnerability there, both to assets and to people? And would this make a strong case for a grant application before I approach the community and say, hey, there's this funding opportunity out there that would really support the work you're doing. You may not have, they were really looking at this as a recreation project, but I think there's, obviously our parks are also a great tool for flood mitigation. And so I come to them and say, I've done some analysis, I have these numbers, I have this information. I think we can make a strong case to pursue funding through this, through another lens, where you're looking at it as a recreational opportunity. I see it as a flood mitigation opportunity, and I can bring this data to support that ask. So it really is both.
And are those communities that you tend to already have a relationship with? Or are they like coming to you for the first time?
So, not to brag, I think we're in a good position as a COG. We work with every single jurisdiction in our region. I myself personally and my staff have projects in every jurisdiction in our region. So we're in a good, we have strong partnerships already with everyone.
Got it. Thank you. Well, I have another question. I don't see any hands up, but let me know if I am missing how I would see those. But I wanted to turn to our other 3 presenters, Jim, Matt, and Kathy, and ask about any challenges that you've had with the work that you shared about, like any surprises or results that you weren't sure how to make sense of it, or you thought something would be possible to access but you weren't, or I'm just curious if you wanted to share any more about the process and overcoming any challenges that you had.
I'm happy to start. So challenges, one of the challenges that we have, I think, is, which comes to light in settings like this, is there's so much good work happening across public sector organizations, and we're all running so lean that sometimes we forget to look up and see what others are working. So collaboration and coordination is really, that's a challenge because we're all doing such great work. So that's one. 2 is an opportunity, which is, I think, trying to think about, we're trying to make the shift to a user-centered approach on both the constituent side as well as a practitioner side. We have access to such amazing data, trying to package it in a way that practitioners can use it is a real challenge. It's an exciting challenge, but I think it is a real challenge.
Definitely, I can appreciate that. Matt or Kathy, did either of you want to?
Yeah, I think it's a really important. You guys hear me okay? Sorry. Let me go first, Kathy, because this is more about the partnership with SEO, but in climate scientists, I think there's a danger when engineers think they can take the data from like GCMs and climate science and apply it to their projects, right? So I think it's really important to reach out to those people that know the science, have spent their time in the science, understand the science. I've been in conferences where engineers will say, "Yeah, we just average all these GCM and the model outputs, and we're just using the average, right?" And it just makes people like, Dr. Kathy and Dr. Bowden and others shudder, right? Because they're not really understanding what's really behind the data. So I think it's really important to bring those people that know that area really well and to be able to provide the information and data to you. So and my point on that is just partnerships are extremely important, right? Because the data is always changing, kind of like Jim said, and we've got to stay on top of it. And the only way we really do that is to partner with those folks that know that science, and then we can, build a better, stronger, resilient network in the future. So.
Thanks, Matt. Yeah, I mean, my challenge is, and it gets to both of these points, is we're serving all 11 million people here in North Carolina. It's a big state. I have the second largest state climate office in the country. I have a staff of 14. We have students. We still can't reach everybody. So we build these tools and they work for some purposes or some people, but we know that there's often a last mile traveled that needs to happen. And that's why I emphasize that we are here as a resource too, as people. I don't want anyone to feel like they can't access climate data or feel overwhelmed, because we are here to walk you through that and trying to get to as many people as we can. But that's why our partnerships matter so much. We love working with the City of Raleigh. We love working with the Department of Transportation. I'm in constant awe of Mary Roderick and everything that she does. So, I mean, these are good friends here on the webinar, but also reaching friends that we don't know yet. That remains to be a challenge for me. How do we reach everybody in North Carolina? And how do we know who is using our data and how they're using it? So if you are using our data, I always want to know about it. So feel free to drop me a line.
Thanks, y'all. Such interesting answers. All right, maybe one last question, unless there are others that come in, is where is your work going next? Either where are you working on a project, or what's your dream project? What would you like to do if you had a lot of resources? Tell us what y'all see in the future.
Can I start? I really want to do more multi-hazard analysis, right? We've got kind of this 5 area, like flooding and this, landslides and this, but we know, and I've said this all along, these hazards interact, and there are complex interactions. And so I don't know yet, and I'd be very interested, and this is where, y'all at the state level could be a great resource for us, to kind of help us get started with how to do this multi-hazard analysis. And I mean, I know, the tool exists, but I don't think that that's really what we want to use. I mean, anyway, it's very clunky, it's my understanding. And so we need the smart people to get together, Kathy, like y'all did with Raindrop, and help us think about how to take this climate data, translate it into this hazard, and understand these multifaceted interactions between hazards.
Totally.
Then we can do that local level analysis.
Yes, absolutely. Absolutely.
I'm happy to go next. I think it's kind of piggybacking on what Mary described, which is, I see this future world, not to go into the AI world, but that modeling the world is a very complicated and sophisticated place. We do have models, and I think Matthew kind of touched on some of the flood early warning stuff, and which is amazing. But those capabilities are just going to grow exponentially. So I'm really excited about this future modeling, where we can understand both current conditions and potential future conditions and scenarios, and understand how things we're doing today may impact us in a day or a week or a year, across a very complex kind of ecosystem. So that's one. And then two, more tactically, is that equity work that we're working on that I think is going to really add value tactically to how we think about and talk about projects, initiatives, and mitigations.
Great, thank you. Kathy or Matt? No pressure.
When you asked that, I was like, well, tonight I will be at the Museum of Natural Sciences on a panel giving another talk. It's Earth Day. It's like tax day for the state climatologist. But I am really excited about the multi-hazard space as well, Mary. So I'm so glad you brought that up. Let's talk soon. But also, I want a North Carolina that feels prepared for the next Helene, that feels safe from the next Helene. I want us to avoid what happened just over 6 months ago. I also want us to reimagine communication. It's not the same. People aren't accessing information the way they used to, and we need to recognize that as practitioners. They may not be on our website. They might be on TikTok or Nextdoor or Facebook, and we need to break out of these mindsets that we have about what is authoritative information and meeting people where they are.
Such a good point. Thank you.
So I guess last but not least, right? I think the focus for DOT is really how do we recover well from Helene, right? We've got a lot of we got 6 majors that we're working on plus I-40, just rebuilding that well, using information we've got from the partnership with the Climate Office to look at service life events for those facilities that are risk-based approach that help us, basically optimize our reimbursements the best we can, so we can bring as much money to North Carolina back, for the rebuild, right? So we only have like one chance to get it right. When you're rebuilding something like this, it's gonna, be there for 100 years or so. So using those informed approaches is really important. And I think the risk-based approach is really important too, understanding what the risk, and you guys kind of mentioned that, the all hazards, but how do we translate that into a risk-based approach where it looks like some of the policy drivers are forcing us right now. So I think communicating well in that space is really important as we move forward to support, the mission of what we're trying to accomplish here.
Amazing, thank you. Well, thank you to all 4 of our panelists. It was such a fantastic set of presentations, all with different angles and different perspectives and levels of expertise on different items. So I just want to say a huge thank you for your time and for contributing to this conversation. And you heard from many of our panelists that they would love for you to reach out if you want to learn more, if you want to work with them. And finally, we have our next edition of the Spotlight on Resilience webinar that I want to mention before we close, which is planning for the heat season. It'll be June 6th at 12:30, and there's a link in the chat to register. And also Nicole Goddard with our team has been very diligently adding a lot of fantastic links to supplement what all our speakers have presented on and discussed. So feel free to go back through and check some of those out. So with that, have a fantastic Earth Day. Thank you all for joining us, and please reach out with if you have thoughts about future webinars or questions for the presenters, please reach out to any of us. Thank you.